In this question from JEST 2024, we are given a cube. Its sides are equal to 1 and one corner of it is at the origin. We are also given the vector potential A is equal to 6i cap plus yz square j cap plus 3y plus z k cap. We have to find the outgoing magnetic flux through 5 phases. We have to exclude the shaded phase. So to do this, magnetic flux is defined as phi through s is equal to integral b dot ds. Here B is the magnetic field, ds is the area element. Now B can be obtained if we take the curl of magnetic vector potential. Now one way to do this is to find the magnetic flux through 5 phases. You individually calculate the magnetic flux through each of the phases and add those 5 integrals. Then you will get the total magnetic flux. Or you can do this by using Gauss's law for magnetism, which says del dot B is equal to 0, which in its integral form can be written as closed integral B dot ds is equal to 0. In words, we can say net magnetic flux through any closed surface is 0. Through any closed surface is always 0. Now, if we are only considering the 5 phases, then it is not a closed surface. So what we do is we also include the shaded surface so that it becomes a closed surface. Therefore, closed integral b dot ds, this is equal to integral over 5 phases b dot ds plus integral over shaded phase b dot ds. Now this is 0, LHS is 0 from Gauss's law of magnetism, which implies magnetic flux through 5 phases is equal to minus of integral over shaded phase b dot ds. Now let us find what the area element is in the case of shaded phase. In the case of shaded phase, area element is dx dy because it is in the xy plane, and the area element direction will be perpendicular to the phase and outward, which means minus k cap. So ds is equal to dx dy minus k cap. This is the area element in the case of shaded phase. Therefore we have magnetic flux through 5 phases. This is equal to minus of integral b is del cross a dot ds is dx dy minus k cap. Now let's find the curl of magnetic vector potential. This is equal to ijk, determinant ijk, del by del x, del by del y, del by del z. Now we have to write the components of A. Component of A is I component is 6, J component is yz square, and then we have 3y plus z. This is equal to I cap times 3 del by del z of yz square is minus 2yz minus j cap del by del x of 3y plus z is 0 minus del by del z of 6 is 0 plus k cap times del by del x of yz square is 0 minus del by del y of 6 is again 0. Therefore we have del cross A is equal to 3 minus 2yz I cap. So this is the curl of magnetic vector potential. Now when you evaluate this integral, you have to put z equal to 0, because this phase, this shaded phase, it is staying at z equal to 0 plane. Therefore we have magnetic flux through 5 phases is equal to minus of integral of del cross A is 3 minus 2yz I cap z is 0, therefore this term will not be there, so there is only 3 I cap here, 3 I cap dot dx dy minus k cap. Now I cap and k cap are perpendicular, therefore their dot product is 0, which means the magnetic flux through 5 phases is equal to 0. Therefore the correct answer here is 0.